So, I will talk you about construction time elevator use and how actually by intelligent project planning this construction time could be even reduced. So, I will start describing the problem on construction sites or the challenge for the transportation, and describe also this simple model of analyzing that. And then there will be, I will introduce two ways how to enhance and make traffic more efficient, and finally conclude the presentation. Okay, so on this construction site, there's a challenge of transporting 1,500 workers to their workplaces in the morning. And in this case, originally there was 6 builders hoist doing the work, which were located here in the background. And this morning rush starts at 6 o'clock in the morning. And even 6:05, there is a long queue of workers waiting for the transportation. So, in the end, it takes 3 hours to take all of these workers to their workplaces. So, the last ones are transported around 9 o'clock in the morning. So, this kind of uptake is familiar in a normal traffic design, and that uppeak is analyzed by this round-trip calculation model. In uppeak, the passengers are heading from the ground floor to the upper floors, and here you can see the destinations of the passengers. And if the passenger demand exceeds handling capacity of the elevator group, then the queues start to form in the lobby. So this is the normal way of analyzing elevators for office buildings and for normal traffic. But it's also well applicable to construction site transportation. So the model is based on uppeak round trip time calculation, which is based on probabilistic quantities. The round-trip time also takes into account elevator dynamics, like speed, acceleration, and door times. And then from this round-trip time, these two important parameters, handling capacity and interval, are derived. Handling capacity just says how much passengers the elevator group can transport in 5 minutes, and then interval just describes how often elevators departs from the ground floor. And this interval also correlates with waiting times. So these parameters are not so easy to use for construction site situation because there are other things that are of interest. So, filling time is the time it takes to transport all the workers or passengers to their workplaces, and that is more interesting parameter for construction site analysis. Average waiting time and journey time are parameters that can be then used to evaluate potential working time savings for a particular vertical transportation solution. Okay, next I will go through a couple of case studies to show how this vertical transportation can be made more efficient. So, first, if the workplaces are arranged so that the vertical transportation can be optimized, that means that in certain cases the round trip time can be decreased. And the best case here is that workers are arranged so that they are on the topmost floors of the served zone. And worst arrangement is that they are distributed evenly on all floors. So this graph describes these different distributions a little bit in more detail. So here is the floor number, and these bars describe the number of workers on each floor. So in the case of even distribution, there is 100 workers on each floor, and then in this zone distribution there is 200 workers on each floor, but only on the 5 topmost floors in this case. And then this triangular distribution is such that the number of workers is increasing linearly towards the top of the building. So with this simple 10-floor example, we calculated the filling time, and the fastest time to fill this building is something like 55 minutes with this zone distribution. And this even distribution resulted in about 15 minutes longer filling time, which means approximately 20% more time required to transport all the workers to their workplaces. So another possibility is to arrange the arrival times of the workers to the transportation. So here the worst case is that everyone arrives at the same time, which means of course that there's a long queue in front of the transportation devices, and the last ones will of course wait for a long time. And best case for this is that people arrive constantly in time. So here is shown the arrival patterns for the 1 hour peak time as an example. And this light blue one corresponds to the case where all workers arrive immediately in the beginning of the shift at 7 o'clock. Then there's another option to stage the arrivals so that the workers arrive in 2 different times with half an hour gap between them. And the last one is the constant arrivals, where people just arrive as a continuous stream. So the resulting waiting times in these cases are shown here, and the shortest ones occur when the workers arrive constantly. So there the average waiting time is only 1 minute, roughly. But as you can see, if everyone arrived in the beginning of the shift, then the average waiting time would be something like half an hour. And this kind of long average waiting time is just because that the last ones have to wait for the whole hour for the transportation. Okay, then I will introduce KONE JumpLift concept and how that improves transportation during the construction time. Okay, so KONE JumpLifts are just ordinary traction elevators that actually utilize the permanent hoist way of the building. And JumpLift is a self-climbing elevator, which means that it doesn't need building cranes during the construction time. The installation platform moves itself upwards as the building moves upwards. And typically temporary machine room is jumping in 2-3 floor jumps. So it follows the construction of the building as it gets higher. And in the end, when this JumpLift is on the top, then most of its parts are or can be used by the final elevator, so that after all, the waste is minimized during the whole process. Okay, let's go back to the challenge I introduced in the beginning. So on this site, they installed 2 jump lifts to solve this transportation problem. And in this end situation, there are now 4 builders' hoists and 2 jump lifts that are handling the traffic. And these jump lifts are have higher speeds than these builders' hoists, so that makes the transportation more efficient and faster. So with this configuration, naturally, the jump lifts are fully occupied during the transportation, and in the end, the filling time for the building reduced to 90 minutes from the original 3 hours. So this kind of improvement in filling time was achieved by the higher speeds of jump lifts compared to these builders' hoists. Okay, so jump lift has certain advantages to boost the construction time, vertical transportation. So it increases handling capacity and then decreases the filling time. And by this, it also saves working time, which also enables faster project execution than without construction time use of elevators. So this is the last case study we had. So this is about a hypothetical construction project of a 50-story building where 1,000 workers need to be transported daily to the workplaces. So in this comparison, 4 jump lifts are compared with 4 construction hoists. And it is assumed in the calculations and that each worker uses vertical transportation 4 times a day. First time in the morning, then twice during the lunchtime, and then again once in the evening when they are going back home. And the project is now assumed to have 2 phases. The first one to concentrate on the lower part on floors 1 to 25, and the second one on floors from 26 to 50. And during the whole project, the use of jump lifts actually saves working time by about 1.5 hours per day per worker. So such a saving per day, of course, results in large savings during the whole project. Okay, then I will conclude the presentation. So in this presentation, I introduced a way how to analyze the vertical transportation on construction sites. So by using this traffic analysis already in project planning phase, this transportation could be arranged so that it maximizes the efficiency of transportation and also reduces working time. But anyway, the savings given by JumpLift, they need to be taken into account in the project plans. so that they can fully maximize the work on the site. And KONE JumpLift can save lots of working time, and that comes more evident in mega high-rise buildings where the travel distances are 200 or 300 meters.